this one's tricky because it's in words. Set of all real numbers greater than or equal to 1 and less than 5. Is that a closed interval? Yeah, one part is like half closed, right? This less than or equal to 5, less than 5 means that it's not closed. If you were writing this in symbols, it would be not including 5. So we didn't go over what it looks like when we have one of each, but you can kind of tell what it's. What about this 310? All right, and this 512. Which of these intervals contains the number 2? The closed interval -6, 0. What about the closed interval 0, 5? What about the closed interval -2, -1? What about the open interval -2, -1? What about the open interval 2.0000001 and -1.99999? This doesn't even make sense, does it? This doesn't even make sense. What's wrong with it? This is saying all numbers that are bigger than 2.0001 and smaller than -1.9999. But there aren't any numbers that do both of those. Now, what if I modified it and I made this be negative? What if I changed this and now I said E star, and E star has a negative 2.00001? Would that fix it? It includes -2. It sure does, because -2 is bigger than this -2.0001 and smaller than this -1.99. So we've already covered, based on this, what do you think the half and half notation would mean? This would mean, yeah, it's like one end is closed, the other end is open. So visually, it's like A is included, but B is not. Everything between A and B is included. Here's a tricky one. I think that these two true-false questions are really straightforward for you at this point. True-false question, I want you to take a moment and think about this one, and maybe let's talk about it before we discuss it as an entire group. C is a positive number, and C over 2 is in the closed interval 0 to C. So take a moment to think about it. You're thinking about this as between this closed interval 0 and 2. C over 2 would be 2 over 2, which is 1. And 1 is definitely in this set 0, 2. And if we think about that numerical example and how we might try to generalize it, things that aren't a specific number, then we could take that, instead of thinking about C being 2, then we could think about it being any C we wanted. As long as it's a positive number so that it's bigger than 0. In fact, C over 2 would be halfway between 0 and C, so it's definitely bigger than 0. All right, now this is the challenge question. This is the one where things might get weird. And I'm going to use a parenthesis instead of a bracket. And the reason is we never use a closed bracket with infinity, because you can never actually reach it. If you used a bracket, you would have to say that infinity, it's a really subtle thing. But technically, if you did a closed bracket, you would have to say that infinity is an element of this interval, because this symbol means that this needs to be included. But that we can't do that. You can't say infinity is in a set of numbers, because infinity isn't a number. No, you can't say infinity minus 1, because as soon as you do that, if you say infinity minus 1 is a number, we're going to have issues. Infinity minus 1 were a number, and you said this is the biggest number ever. Problem with that, which is I know a number that's bigger than that. I was just going to say add like 0.05, so it was still in the, but you're right. If we can subtract 1 from infinity, why can't we add 1 from infinity? And then why can't we add 10 to infinity? And then so there is no largest number in this set, because whatever number you tell me is the biggest, I can add 2 to it and get a bigger number. And like, I have to do a better job of this, because this is an incredible insight. Knowing this means you know something that some of the smartest people in history did not know. Pythagoras didn't know this. Pythagoras didn't even think that there were irrational numbers. One of his students proved that square root of 2 is irrational. Pythagoras had him murdered, so he couldn't tell anyone. They were very, very serious. He was a very, very powerful man. He was able to insult the king and insult the emperor inside his school. Maybe? I don't know that one. I know that the king showed up and said, will you teach me geometry and make it fast? Pythagoras said, I can't teach geometry quickly, because you can't learn geometry quickly. And then Pythagoras started teaching geometry, and after about 30 minutes, the king said, what is this good for? And Pythagoras turned to one of his students and said, give this man some money, because he needs work. Like, if you're really worried about practical applications, and and I understand why Pythagoras said that. My question is, how could he get away with it? Like, to call a king a beggar, that's power. The President of the United States were here and said, I want to learn calculus. And I started teaching it. And he said, what's the application of this? And I said, what, you need a job? Think about that. That's stunning. That's the power of math. All right. Is there a smallest number in this set? No. Whatever number you tell me is the smallest one. So I'm going to say, I don't know what the smallest number is. I'm going to say X, smallest number. Can you come up with a smaller one? Let's see. So it depends on the value of X. So you say X divided by 10 is smaller than X. So you say no. X divided by 10 is smaller than x, but greater than 0. So that means that x is not the smallest number. No, it doesn't work because x divided by 10 is positive. I'm going to say x is the smallest positive number. You're going to tell me no, x divided by 10 is still positive, but it's greater than but it's smaller than x. That's why infinity's end is a funny idea. I used to ask this question in my college algebra classes. I'm not making fun of them. I think this is a really common human idea. They would say the smallest number in the set is 0 point infinitely many zeros with a 1 on the end. And the fact that this actually goes on forever and that you can't stop and put 1 on the end